Hello. Can we move to the next question? So we have next question uh, on this vector application. In these questions, the distances are measured in kilometer, and we have given the two boat velocity. And one good point is here that both of them is starting from the origin, relative to the origin. So this is a good point for us. It's not mix too much complicated. So their position vector at time t after midway are given by the boat A and boat B is like this, and we are looking for the minimum distance between these two boats. So I'm hypothetically saying, let's say for example, both of them since starting from the origin. So I'm drawing the hypothetical. This is not the actual one. So let's both of them is starting from the O, and A is going like this and B is going like another way. So to measure the distance between them, right? These two at any point of the time. This one. So what I'll say, it will be Ra minus Rb, right? Ra minus Rb will represent basically the distance, right? Since, for example, let's say I'm measuring the distance like I'm going like this and this. So I say that I'm going along the Ra and then in the opposite direction of B. So that's how we make the vector, right? If you let me again make it clear. So from the origin, the boat A is going like this. From the origin, boat B is going like this. So I need to connect these 2 points, right? I need to connect, and I am connecting like this. I'm connecting like this, right? Or it's up to me. Like I can also connect it like another way, like in this way, right? Right. Yeah. So to write this vector, this one, I'll go in the opposite direction of A and along the direction of the B, right? So I say it is RB minus RA. If this is RA, this is RB, so it is RB minus RA. So this vector that I need to develop is RB minus RA. And once I develop this vector RB minus RA, right, what I'm going to do? I'll figure out the magnitude of RB minus RA, right? And once I develop the magnitude of RB minus RA, I'll draw this expression again in my calculator, graphic display calculator, and ask my calculator to give me the minimum. Are you getting this point? So yeah, so first plot the RB minus RA expression. RB, which is minus 2 plus 5t, 9 plus 0t, so it's just 9, minus RA, which is minus 4 plus 4t, 3 plus 3t, and create the equation minus 2 plus 5t minus minus plus 4 minus plus minus 4t, 9 minus 3 minus 3t. I'm going right, and next I will make 5t minus 4t is t, minus 2 plus 4 is plus 2, 9 minus 3 is 6, and this is minus 3t. This is what I'm getting the expression for RB minus RA. Okay. Now what I need the minimum distance. I need the distance. So I'll do, I'll find out the magnitude of RB minus RA. For that, I'm doing t plus 2 whole square plus 6 minus 3t whole square. Right. And to get the minimum distance, you can either go with the calculus method to figure out the gradient, and then from there you can figure out all those things, or you can draw it on your graph. Right. Yeah. So drawing it on the graph, x plus 2 whole square, so bracket x plus 2 bracket whole square plus 6 minus 3t, 6 minus 3x bracket close whole square. Okay, at this time we are getting the right one. So I'm getting this graph. I'm putting it here. Hmm. See, this is the graph I'm getting. Here you go. This is the graph I'm getting from the Desmos. So the coordinates 1.6 is the x coordinate, which is the time here. So at t is equal to 1.6, what is the unit of the time here? An hour. So it's 1.6 hour, and the minimum distance d is 3.79 kilometer, of course. This y-axis is representing the kilometer. Right. This is the minimum distance. Are you getting this? Giving the very similar question, only little bit change. This was find the minimum distance between the 2 points. So we got the minimum distance between the 2 point. I'm giving the very similar problem, very similar sum. This time find the time when the distance between two of the tanker is at the minimum, and they start measuring it at two tanker A and B are observed from the origin O relative to the O, their position vector at the time t hours after 6 p.m. So they'll start measuring their distance after 6 p.m. So figure out that time, add it to the 6 p.m. and check out what is the time exactly that would be. Did you get that time? Hmm. Yes, the graph is saying the same thing. So time is 3.6 hour. So from 6 p.m. to plus 3.6 hour, we will reach where? 9 hours 6 p.m. This is the time when the distance is the minimum, which is 4.91. Oh, yeah, okay, yeah, that's also the thing that point 0.6 we need to, that's in minutes, so you need to check that out, how much it will be. So let me back this up. So if I write 3.5, it's 3.5 hour. And if it is 3.6, then I think I believe it will be uh, 9.930, and this is actually 936. 936. 0.6 multiply with 60, 36, right? This zero point 0.6 is what? Zero point 0.6 is hour. And to check how many minutes it will be, zero point 0.6 times 60. That is 36 minute. Okay, so it's 9:36 hours PM basically. Okay. Distances are in meter in this question. Jack and John are flying airplanes in a straight line at a constant speed. Jack airplanes passes through point P. Its position t seconds after it passes through P is given to us. Write down the coordinate of P. Find the speed of the Jack airplanes in meter per second. After 6 seconds, Jack airplanes passes through Q. Find the coordinate of Q. Find the distance of the airplane has traveled during the 6 minutes. I mean 6 seconds. Then John airplanes comes into picture, and that passes through point R, and its position as seconds after it passes is given by this another vector, velocity vector, and we are looking for the point of intersection of these two planes and who is flying faster. So we have the velocity vector given. Okay, so what would be the coordinate of point P? Jet airplanes pass through point P and its position t second after it passing through P is given to us like this one, right? So at the point P, the position was 5, 8, and 2, right? Because this velocity vector that's given to you is given after it passes through point P, and P is that point where it's starting, right? Basically here. And where is the velocity? Velocity is minus 1, 2, and 3. So the speed would be magnitude of minus 1, 2, and 3. That is 1 plus 4 plus 9 root under 14. Root under 14, which is in the significant figure will be 3.741. So it is 3.74 meter per second. That is the speed. Find the coordinate of q, which is after 6 seconds. So it will be 582 plus 6 times minus 1, 2, and 3. So it will be minus 6, 6 times 2, 6 times 3. So that is 5 plus minus 6, 12 plus 8, 2 plus 18. This is my coordinate after 6 seconds. That is the Q. You can write as OP. You can write as OQ. Find the distance of the airplane has traveled during the 6 seconds. So distance again we have to find. So distance is from P to Q, right? So the distance that is travel is from P to Q. And P to Q means what? Q minus P. That's how we find out the things, right? OQ minus OP. What is OQ? Minus 1, 20, and 20. And what is OP? 8, 5, 8, 2, right? So it's minus 1 minus 5, 20 minus 8, and 20 minus 2. This is the positions. This is the vector that we are getting for the distance, and to get the distance, what I'm going to do? I will find the magnitude of PQ. That is minus 6 square plus 12 square plus 18 square. Do that in the GTC. Six root 14. 6 root 14 is 22.449. So 22.4 meters. This will be the distance. To find the point of intersection of two vectors, we discussed like how do we find the point of intersection. Remember, if you uh, we have done this like the to finding the point of intersections. Yeah, basically, yeah. Basically, we equate R1 and R2, right? R1 and R2. R1 is a little bit short. R1 is, let's equate one by one. X with the X. 5 minus T will equal to 4 minus S. 8 plus 2T will equal to 4 plus 5 times S. 2 plus 3T equal to 5 plus 3S. From here we can get the combination. So it is, let's say, uh, T will come this side, so it become T minus S is equal to 5 minus 4. This is one of the equation, and let's say 5S minus 2T is equal to 8 minus 4. That is my second equation, and I think this is enough to solve S and T. So if I substitute here T, which is 1 plus S, 5S minus T, which is 1 plus S, that's equal to 4. So it's 5S minus 2 minus 2S is equal to 4. 5S minus 2S is 3S. 6 plus 2, 4 plus 2 is 6, so S is equal to 2. S is 2, so T will be 1 plus 2 is 3. S is equal to 2 and T is equal to 3, right? S is equal to 2, and so find the coordinate. So to get the coordinate, you can put this uh, respective S or T in their particular given vector to get the coordinate. Like for this value, you're not going to put it in R1, and for the T value, you're not going to put that into R2. Of course, this is very clear that we have to put S in the place of S, and of course, we're going to get the same thing. For example, if I put that S here in the R2, it will be 4 plus minus 2, and it's 4 2 times 5, and 5 3 times 2. So what I'm getting coordinates 2 14 11. If I put t is equal to 3 here, I'll get 5 3 times minus 1, and 8 plus 2 times 3, 2 plus 3 times 3. So yeah, if you see, we have the same coordinates again. So this is that position, this is that coordinates. Yeah, this is the coordinates where they basically meet, right? And determine who is flying faster. We already have the speed of Jack airplane. A part 2. Oh, I just erased that one. A part 2. Yeah, I wrote it here. A. We already had this. All right. So 3.74. Let me write it here. 3.74 meter per second. That's the airplane of Jack speed, and now we have to find John. So John velocity representing is minus 1, 5, and 3. To get the speed, I'll do the square root of minus 1 square, 5 square, 3 square. So it will be root under 35, 5.91. Yeah, it is higher as compared to this one. 5.91 is higher as compared to, it's actually 5.92 because it's 5.916, which is 5.92 is greater than 3.74. So John plane is having a higher speed as compared to Jack. Yeah, speed is not having any magnitude, so it's just the magnitude of given velocity. This time we have the new sum. The particle P moves with the velocity v, that is 2 minus 5, 4, in the magnetic field B A02. A belongs to real number. Given that the velocity is perpendicular to B, find the value of A. Velocity is perpendicular to magnetic field, so we have to figure out the value of A. So we can go with the multiplication of vector. We have the two types of multiplication of vector, a scalar product and the vector product. So if we have A dot B, how do we open that? Mod of A, mod of B, cos theta, right? So if these two vectors A perpendicular to B, then their dot product is what? Equal to 0. So yeah, I can say that V dot B will equal to 0. If they are perpendicular, then since V is perpendicular to B, so 2 minus 5, 4 dot A02 is equal to 0. And how do we open this up? 2 times A plus minus 5 times 0 plus 4 times 2. Alright, so what I'm getting, 2A is equal to minus 8, therefore the A value is minus 4. Next part, the force F produced by P moving in the magnetic field is given by the vector equation. The force is BV cross B, and B belongs to positive real number, and we are looking for the value of B. And we also have the magnitude of force, that is 18, which will going to help us to find the value of B. First you need to do the force This is BV cross B. So we have the V, we have the B, so we can cross them. B is just the scalar multiplication with the V, right? B is just the scalar multiplication with B. We can handle that out, but first we need to do the V cross B. Check this out. What will be V cross B? Yeah, please do that in that way, whatever way you have learned. A is minus 4, 0, Z plus 2K. I'm doing it here in my way. I, Z, K, 2 minus 5, 4, minus 4, 0, 2. Alright, so for the I vector, I'll have minus 5 times 2. Done. Great. For the G vector, we have 2 times 2. Minus, minus, plus. 4 plus 16, 20. Good. For the G, we have 2 times 0 minus, minus 20. Okay. So check the answer if you have. Alright. For the last one, I just need to check here if I cross this one. 2 times 0 minus of this will become positive. So my last one will be basically minus 20. This will be also minus 20. Minus 20k. So if I take minus 10 common here, it will be I plus j plus k. It's 2j 2k. Up to you, it's not like, yeah, it's okay. That's up to us. We can write in IJK, we can write in column vector like minus 10. Okay, so now come to the next part, which is the B, which is a scalar which is multiplying with V and then cross, of course. So I'll just write F, which is mod of F, which is 18. So B multiplying with, of course, minus 10 and all this thing. I plus 2j plus 2k. So I'm having a mod 18 is equal to minus 10b I plus 2j plus 2k. Now, if I have to just take the mod of one side and put the mod on the other side, because if I put this mod out, I'll need to put the mod this side also, right? So if I have to erase that mod, I'm going to put mod in this side. So it will be mod of minus 10b and mod of I plus 2j plus 2k. So 18 is equal to mod of minus 10b is just 10b, and this is root under 1 plus 4 plus 4, which is 18 is equal to 10b, and it's 4 plus 4, 8 root under 9. So it is 18 is equal to 10b times 3, and 3 is 6 times 18. So 6 is equal to 10b. Therefore, my b is 6 by 10, which is 0.6. Okay. All right. So I think we are done for today. Uh, Let me put that to screen here again. Yeah. Tell. Yeah. No, this is not the magnitude of f. Magnitude of f is also multiplying with one scalar, which is b. So yeah, yeah. If you see here, that in the given problem, it's here. If you noticed, the force is uh, b dot v cross v b, right? So we cross it, and then just be just a square multiply. So I just multiply that with the given answer. Yeah, 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 yeah. Yeah. All right.